Well, when we were together last time, we were talking about the concept of data types, which you have seen in other programming work you have done. I'm quite confident this is certainly not something that is unique to ABAP. But one thing that is somewhat unique to ABAP is the idea that we have two broad categories of data types. We have complete data types, which the idea behind a complete data type is by saying that a data object is of this type, that's all you need to say. For example, the concept of an integer. We could say that this particular variable is of type integer, and that's it for the declaration of the data object, because designating it as an integer is in and of itself sufficient information for the system to know how to handle the information. But the other kind of data type that we have are called incomplete data types. Incomplete data types require us to not only specify the data type, but also to let the system know what size of space needs to be allocated for data that is going to be stored in that particular data type. Where you have probably seen this concept before in other programming languages is when you create a string or a character array, and you might say, give me a string capable of holding 30 characters or 50 characters. And so in other programming languages, when you create a string, it's not uncommon to have to specify the length that you expect that string to be. Well, in ABAP, we do that same kind of thing with a variety of data types. And so this is where we will jump into our discussion for today, talking about both complete and incomplete data types and how we declare them and use them in our programs. So, integer is a complete data type. Now, what I want you to make sure you understand here is in this table that's going to populate this slide, the actual data type is what's in the leftmost column. So although we might call this an integer, the actual data type is just the letter I. So if we create a data object of type I in ABAP, we get an integer value capable of storing a 4-byte whole number, which gives us the ability to store numbers in the range of positive to minus 2.1 billion, which is going to suffice for most times when we need a whole number. Data type F, or float, is also a complete data type. All we need to do is say I want a data object of type F, and I get a floating point data object. 8 bytes of storage is allocated, so we can store a decimal number with 15 to 16 significant digits. Well, our first incomplete data type is C. This is capable of storing alphanumeric characters, and notice it can store up to 65,000 characters. Now you might say, why in the world would I need a string capable of storing 65,000 characters? Well, the idea here is this might be a small text file that you would get from some source and store that text file in a data object in your program. So the point here is when we create a data object of type C, we not only need to use that type name, we're also going to have to tell what size C we want to be able to store in this data object. And I'll show you how to do that in just a moment. N is a numeric string. Once again, this can be up to 65,000 characters. And the idea behind a numeric string is this is going to be a sequence of numbers. It has to be numbers. It can't be alphabetic characters. But it's going to be stored like a string in that we can't do math on the numbers. So what would be an example of something that we might work with in our programs that would be a numeric string. Lots of good ideas. I heard someone say phone number, and that's a good one. What else? Zip code would be another one. Maybe an ID number. You know, the idea is something that's a number, but you're not going to do math on it. And by the way, when I said ID number, that could work as long as the ID number is truly nothing but numbers. If it has alphabetic characters in it, I can't use a numeric string for that, but I could use a C string for that. So we have string, we have numeric string, and then, not trying to be confusing, there is a data type called string. The distinction here is you'll notice this is a complete data type. Incomplete data types, I say at the bottom of the screen, are the ones that are in bold italics. So string is a complete data type, so I just need to say string in the data object declaration. And notice this, not aware of any other programming language that gives you this. This is a dynamic length string up to 2 gigabytes long. Now, why in the world would we need something 2 gigabytes long? Well, going back to what I said a moment ago, this could hypothetically be an entire data file that we bring into our program in a single data object for manipulation. Quite frankly, we're not going to do anything with strings that length in this course, but it is kind of notable that when you talk about using a string in your program, you, for the most part, aren't going to have to worry about whether or not it's going to be long enough for your application. Notice that this is a, well, that was really interesting. I circled dynamic length, and the circle showed up at the bottom of my screen. I have no, so let's see if I can just like, no. Oh, well, that's really kind of funny. Yeah, well, and what's funny is I have to erase it in the wrong spot too. That's a weird one. Don't know what's going on there. But I intended to circle the word dynamic there. Dynamic means that if I put the name Bob in there, the computer's going to allocate enough space for storing Bob. It's not going to set aside 2 gigabytes of storage just to store that small name in it. So the string will expand or compress to whatever size is actually needed in the context of my program. X string is a hexadecimal string. So this is a dynamic length byte sequence. Same size as the string, 2 gigabytes long, but notice here, whereas opposed to a string is simply alphanumeric characters, an X string could actually store like a photograph or some other kind of file that might not strictly contain alphanumeric characters. We really won't use the X string in our programming this semester, and candidly, I don't know that I've ever seen a program that uses X string in it, but it does have utility in certain purposes, and so I wanted to give you a complete list for the sake of our discussion. X is a byte sequence up to 65K. So this is, you know, just like C and string are kind of related to one another, with the distinction being one's incomplete and one's complete. X string and X have that same relationship, where X is a byte sequence capable of storing pretty much anything in it, but you're going to have to declare the size. And the maximum size for that is 65,000 bytes. Once again, we won't really do anything with those, with that particular data type this semester, but I wanted you to be aware that it existed. D is a data type for storing dates. Now notice how the date is actually going to be stored. It's going to be stored as characters in the format YYYY, so 4-digit year, 2-digit month, 2-digit day. So for example, today would be stored as 2017-01-26. So this is a character string, but it's a specialized purpose character string that is capable of holding dates. And so we want to use it for that particular application. One thing that is notable, well, I'll say more about dates on the next slide, so I'll hold off on that comment. T is a data type for storing time. This is stored similarly to date in character format, where the time is hour, hour, minute, minute, second, second. Now you will get to work with at least one of those two data types for the sake of your homework assignment. And the important thing to note here is the system will store it in the format that we are illustrating here, but when you actually go to, let's say, produce it on the screen, you have the ability, through options in the write statement, to decide how this is actually rendered. So for example, even though it's stored 2017-01-26, you could render it to the screen excuse me, as 1/26/17 or 01/26/2017. You have a variety of options there in how it's actually rendered to the screen. But by default, if you just write it to the screen, you're going to get it in the same format that it's actually stored in. Now, P is a packed number. And I'm going to have to explain to you the rules of packed numbers and why they are very, very useful for us and something that we will use a lot this semester. A packed number is a precise, could be a whole number, could be a floating point number, up to 16 bytes in length. Notice this is an incomplete data type, so I'm going to have to declare what size it is. Now, the sizing rules for packed numbers are really interesting, but before I go through them, let me explain to you why I need packed numbers. Let's say, for example, that we're working with account data in our ERP system. And so one of the things that we store in accounts quite frequently is dollar values. So we might have an account that has a balance of $127,686.17. And we might need to do some kind of math calculation on this, such as figuring out interest earned and then adding that to the balance or whatever have you. Now, I don't know whether you have seen this firsthand in your programming. My hope is that perhaps this is something you've talked about in other classes. But you know that when computers do math, particularly floating point math, a lot of times the answer the computer comes up with is not necessarily the same answer you would get if you worked it out on paper yourself, because of how it does the calculation and how it moves around significant digits and other things of that sort. Lots of times the answer does correspond to what you think it would be, but sometimes you might do a calculation and you might discover that you expected a particular number of cents, and when the computer calculated it, it came up with a different number of cents. Well, that's really problematic for us in the context of an ERP system where we do a lot of handling money. So what a packed number allows us to do is say, I want a number of a certain length. I want this many digits to be to the left of the decimal sign. I want this many digits to be to the right of the decimal sign. And interestingly enough, when the system does math using packed numbers, ABAP does the math as opposed to passing it off to the CPU's math calculation engine. And the rules that ABAP follows is it does math presumably the same way you were taught how to do math in elementary school. So you will get the mathematic answer that corresponds to the way that you would get this if you worked it out on paper, and it cuts out that drift of decimal values or other things that might occur if we had the computer do the math for us. So, as you can gather from my discussion here, we will use packed numbers a lot when dealing with currency values. But it also has other value for us in situations where we would say, I want to store a whole number or I want to store a floating point number, but what I want to do is I want to make sure that the mathematical manipulations of this are done in a manner that I could replicate myself. Yes, sir.
So math is done on the ABAP side.
Yes.
Does that ever bog it down?
Not usually. I don't think, I've never heard of that being a target of something that we would need to concern ourselves with in performance tuning. Now you'll notice this is an incomplete type. As we're going to establish in a moment here, most of our incomplete types are pretty straightforward. For C, if I want a C data type, I just have to tell it how many characters I plan to store. For the X data type or the N data type, same thing. I want a numeric string capable of storing 8 characters. So I declare it to be of size 8. The way I declare sizes with packed numbers is a little bit different. I have the ability to create a packed number up to size 16. So a packed number will be 1 through 16 in its size. Now, how many digits do I actually get? Here's the rule. I take the size specifier and I multiply it times 2, and then I subtract 1 from that result, and that's how many digits I get. So you'll notice this number I put here on the whiteboard a second ago, 127,686.17. If I knew that this was going to be the largest currency that I would be using in a particular content, I would look at it and say 1, 2, 3, 4, 5, 6, 7, 8. So I need to be able to store 8 actual numeric characters. So if I look at the math here, okay, so how big does my pack number need to be? Well, if I were to declare it to be of size 2, 4 times 2 is 8, minus 1 is 7, that's not going to be big enough. But if I make my pack number to be of size 5, 5 times 2 is 10, 10 minus 1 is 9, 9 will work here. Now you might look at that and say, why in the world do I have to do this math on this? Well, first of all, pack numbers, the 1 through 16 designation is based on bytes. And a byte can actually store 2 numeric characters. So that's why we do the multiplying times 2. Why do you think we do the subtract 1? That's a good guess, but it's not actually the decimal. There's something else, though, that's part of this number. Sign. I heard someone say sign bit. Okay? So that is what this minus 1 is. So once again, when I'm working with pack numbers, what I have to do is I have to think about, okay, what's going to be the longest number that I have to work with? And so I count how many places that is. And then I do the math to make sure that I declare something to be of appropriate size, where the size, once again, is the size I declare times 2 minus 1, and I will have the ability to have that many digits. Now, the next question is, how do I know how much is to the left and how much is to the right? You don't worry about that in the size calculation, but I will show you how you account for that in the data object declaration here in just a moment. So these are the data types, many of which you will work with this semester, a few, though, that are more specialized that we will not. So let's talk about a couple of things related to these data types, and then we will show you the code to go along with this. One of the questions that's pretty obvious here, I think, is how do I know when to use a C versus when to use a string? We said the difference is C is an incomplete data type, so I have to give a size. String is a complete data type, and it's dynamic, so the system worries about the size. I don't have to. The trade-off here is efficiency versus flexibility. And in particular, if you think about it, string carries with it a fairly minor amount of extra overhead, as the system has to be prepared for the size of the string to grow and shrink dynamically. And the system also has to, on its own, keep track of the actual size of the string at any given time. So although this isn't a major issue, computationally, it does introduce a little bit of extra overhead. However, if we know a data object will never be bigger than a certain size, our best bet is to use C as the data type. But if we have a question as to how long a particular string might be, then we use string. So here's my question to you. How could you, in a program, be able to create a data object of type C and know with certainty that you'll never actually have to process data any longer than the value that you declare? What kind of scenario do you think might come up with frequency where we would know the maximum length of a character string? Any ideas? What's that? Okay, that could be an example of that, but license plate numbers are, you know, if we're writing an international application, could be different in France than it is here in the United States. Could be different here in the US from one state to another. Could be, but once again, I don't know that that's the best answer here. It's not a bad answer. Okay, but there's no fixed length for that necessarily that would be universal. Let's back up and let me ask you another question. We're going to be processing a lot of data in our programs. Where is a good chunk of that data going to be coming from and going to? What's that? Database tables, right? When you create a database table, can you tell that database table, store this character data and make it any old size the user wants to put in? You can't do that in a database table design, right? You say, I want this field in my database table to be this many characters long. So if we know, let's say, for example, that we're working with a database table, that the database table is being used to store customer names, and the longest possible last name the database table will accommodate is one that's 40 characters long, then I can declare a C data type that's also 40 characters long to give me correspondence with data that's coming from the database or going into the database table. So if we think about the idea that a lot of times the data types that we choose are reflective of database tables where the information will be stored or retrieved from, I think it makes it easier to understand why sometimes you might know definitively what the maximum size of a character string would be. And so that's why C is very, very useful for us. You know, in some programming languages, you have security issues with buffer overflow. By that I mean you ask the user to type in a character string and they sit at their computer keyboard and type for 20 minutes and hit the enter key, and your program tries to swallow all of that data and crashes as a result. ABAP doesn't work that way. If you say, end user, give me a character string of up to 20 characters, it'll take in up to 20 characters and then basically turn off their keyboard so they can't type anymore. So that gives us a level of security here. So sometimes we really do know what the size of a character string will be, and in that instance, C is our best friend. It's also why using string as a data type for storing someone's last name isn't really useful, because the user could type in a last name that's 547 characters long, but I'm going to have to put it in a database table that only allows for 40 characters. So why did I do that? You know, I want to set my program up to be reflective of where the data is ultimately going to go. So you'll see this more in actual programs that we write, but that's the driving concept behind when we choose which of these to actually use. The other thing to make note of before we start looking at specifics here is, let's talk for a second about working with date and time. I said that these are stored as characters. They're not stored as numeric values. That's to give us precision. But unlike numeric strings, and unlike strings and C strings, I can actually do math on these D and T data types. If for D I add 1, that's the equivalent of saying 1 day in the future. If I subtract 7, that means 7 days in the past. So if I want to move forward 1 month, that might mean adding 30 or 31, depending upon what month we're looking at. But I can add or subtract from the D data object, which causes the days to be manipulated. With T, adding and subtracting changes the seconds. So if I wanted to say 3 minutes in the future, I would add 180 to the value that is in T. So that's kind of an odd situation in that it's character-based, but I can actually do math on it. And the reason for that is pretty straightforward. Obviously, people do want to, from time to time, do data manipulations on dates and times. All right, so what's the syntax for actually making data objects? Basically, the syntax is the keyword data, the name for my variable, the name for my data type, or excuse me, the name for my data object or variable, the keyword type, and then the type specification that relates back to what we saw 2 slides ago. So for example, if I wanted to create an integer capable of storing someone's age, data, age, type, I, you'll recall, is a complete data type. So I don't have to specify the size. So that right there is a complete declaration for that particular variable creation. I can initialize a data object at the type of creation. I do that with the keyword value. You might recall in an early discussion, I mentioned to you that there were over 800 keywords in the ABAP programming language. I think you're starting to see why. We multiply keywords like crazy. You know, here in just data declaration, we're going to see we probably have at least 8 or 10 keywords that we use from time to time. So I can, for any data object declaration, add a value clause to it to set the default value, which of course can later be overridden in my program. How do I work with incomplete data types? Well, I have to add to that declaration a length clause. So here, data state, type C, length 2, value TN. Now, the value TN here would be optional, but the key is that state is being declared of type C, so I have to tell the system how long for it to be. So I always use the word length to declare the size of a particular data object. Now, all of these statements that I have shown you so far are syntactically correct and valid. But what I will often do in my programs is this is a great place to use a chained statement. So here you see a similar code sequence, data colon, age, type I, comma, and you'll notice what I've done here. I've gone to the next line, and then I'm lining things up here vertically, siblings, type I, value 7. Don't need a length specifier for either of those because those are both complete data types. Be aware that there are other variations that are considered obsolete. Your book shows you the new contemporary ABAP syntax, but in the past there was other alternate syntax that you could use here that was a little bit cryptic, and prone to people making errors. So that's why we use this newer syntax now. I'll show you, I think, on a later slide what the obsolete declarations look like. We don't want to use those. I can, as opposed to declaring a specific data type, I can use the keyword like and tie that to another data object as essentially a way of saying, give me another data object that is the same type of this other data object that I have already declared. So the idea here is it's going to say, okay, data state to like state, and it's going to say, okay, what was state? And it's going to come up here and say, oh, state was type C length 2, value TN. Now what's particularly important to note here is only the data type is copied. So in this case, state 2 is going to be of type C length 2, but it's not going to be set to Tennessee. The value part of that is just totally ignored when we use the like clause. Let's talk about the like clause for a moment, because you might be inclined to look at that and say, why would I ever want to do what we're seeing here? And quite frankly, this example, you wouldn't want to do that. You know, if I needed state 2, I probably would just, in the context of a change statement, I would do state 2 type C length 2. But there are times when like is a really, really great data type for us. And the key is, and you're going to see this theme come up a lot, we've talked about it already once today, we do a lot of ABAP programming in conjunction with database tables. So what the like statement allows me to do is say, and I won't give you the exact syntax right now, we'll see it soon enough in the future, but let's say that I'm working with a database table, and in that particular database table, there's a field here called fname for first name. I can say data and give the name of a data object like and list the name of this table in this field. And it will automatically go out and check the database table and give me a data object that corresponds exactly to what that database field is able to store. So that's really, really handy for me to make sure that my program is set up to work with the actual kind of data that's going to come from the database. And it also gives me the ability to write my program in such a way that if the design of this table ever changes, my program automatically adapts, because my program's just going to go out and check the database table as a part of deciding what size or type a particular database field, or excuse me, a type of data object should be. Any questions about this so far? Yes, sir.
There's similar names in multiple tables.
That's why what I have to specify here is both the name of the table and the field in the table. And so I'll show you this. The syntax for that is pretty trivial, but we'll look at it later. Other questions? All right, I think I have one more point here. When specifying default values, like up here I did data siblings type I value 7. Suppose I wanted to do data pi type F value 3.14. Well, if I put in my value clause 3.14, I got a problem. Why do I have a problem there? Yeah, as soon as it sees this period, it thinks that's the end of the statement, and it wonders what in the world that 14 is doing hanging out at the end of the line there. So to solve that, I've got to put single quotes around this, which normally, of course, is the way that I designate strings, but in this context, the system's going to say, oh, we're working with a floating point number. He or she is using that to tell me what the floating point number should be. So we don't do that with whole numbers, but if we're setting a default value that is a character string, like Tennessee right here, or something that has a decimal point in it, we use the single quotes. Why don't we use double quotes?
It's a comment.
Yeah, double quotes are like I've illustrated here. They always start a comment block. So we never use double quotes for anything in ABAP other than to end-of-line comments. Something that perhaps you'll have to get used to. Now, I'm going to show you, as we continue here, more about how to work with the length specifier for incomplete data types. But it is important to realize that if I leave off the length specifier for an incomplete data type, I am not going to get a syntax error, but I will have just created a logic error in my program, because every incomplete data type has a default length. And it just happens to be that the default length of something of type C is 1 character long. So in this situation right here, if I left off length 2, the system would not at all complain, and it would take that T and put it in state, and in the rest of my program, state would only be able to be 1 character long, which clearly is not what I intend. So the rule we want to follow is, with incomplete data types, even though you might say, well, I do want a C of length 1. Well, go ahead and put that in explicitly, length 1. Never rely on the default lengths for incomplete data types, because most of the time it's an error on the developer's part when they do that. So what I have at the top of the slide here related to variable declarations is accurate, but it's incomplete. Let me show you a more complete data statement. Data var name, type, then the name of the type, length, if we're looking at an incomplete data type, decimals, if we're looking at something with a decimal portion, and then value, if we're looking at something that's going to have a default value. Probably need to fix my slide, which I will do here, because there really should be a dot at the end of that line to make that to be a valid sentence. So that's the more complete pattern for what a data declaration would be. I only use length if I'm looking at an incomplete data type. I only use decimals if I'm looking at something that's going to have a decimal portion to the number, and I only use value if I want to declare a default value. So let's look at some examples of this. Data text buffer, type string, value text. Okay? String is a complete data type, don't have to specify length, obviously don't have a decimal portion there, but I can specify a default value. Count, type I, value 1, similar to code we've looked at before, but now notice the next one here, price, type P, packed number, length 8, decimals 2, value 1.99. All right, let's take that statement apart. Length of 8 gives me a number capable of storing how many digits? 15. I take that number, multiply it by 2, and subtract 1. 8 times 2 is 16. 16 minus 1 is 15. So I have a 15-digit number, of which 2 of those decimals, or 2 of those digits, will be to the right of the decimal place. That's what the decimals designation is. I declare how many digits I want to the right of the decimal place. You probably have noticed when you go and buy gas, gas always seems to be sold to 3 currency digits. It's always like, it's never like $1.05. It's like $1.05 and 9 cents. I don't know why they do that, probably just a way of tricking you into thinking you're getting a better deal than you really are. But it's just become conventional in gasoline. So in that situation, I might have something that would be currency, but I would have 3 decimals of precision. And we really do want to get in the habit of using packed numbers for currency, because have you ever written a program in another language where you're manipulating currency, and maybe at the end of your program you print out like the total, and it prints out like 3.1462859, you know, and that's of no use to us, and so you have to write extra code to round and things like that. We don't have to do that in ABAP. We just say, hey, give me 2 decimal digits, and then in any manipulation it's going to do, it's always going to adhere to that, automatically rounding, as might be appropriate given the result of the calculation. I mentioned deprecated format. Here's just an example of that. The old format used to be this data statement, the name of the variable, and then you would put the length in parentheses, and then you would finish out the rest of the type statement. So this up here would correspond to what we're seeing down here, data price 8, type P, decimals 2, value 1.99. Don't use that. You know, that's considered deprecated, and in fact, if we tried to use that syntax in the context of an ABAP objects program, it would be designated as a syntax error. So you might see that format show up if you do like a Google search for ABAP code, and it's code or web page that's been out there for a while. So don't do that. That'll cost you a point or so on your homework if it shows up. I have this note here, your book shows the deprecated format in places. I think that was true of the book we used last year, and I just didn't update this slide accordingly. So I don't know that your book for this semester will ever show you that deprecated format. Questions? Okay, so what can we do with data objects? Well, obviously, we can do math. So let's talk about the math operators in ABAP, and we're not going to take a long time to talk about this. We're just going to observe we have plus, minus, times, slash for whole number division. We have the double star for exponentiation. So like 3 squared would be 3 star star 2. 5 to the 4th power would be 5 star star 4. We have div for integer division, so 3 div 2 is 1. We have mod for the modulus operator, the remainder basically from integer division. So those work the same way they've worked for you in other programming languages, with the exception of you might not have had exponentiation as an operator in other languages that you have worked with. There are, of course, rules of precedence for these operators that pretty much follow the explicit rule or the normal rules that you learned in math class in high school or before or after. I'm not going to go back through those order of precedence rules, but I will say this. If you are ever doing a calculation that has the potential to be confusing because of order of precedence, just use parentheses in your code. Even if technically you don't need to, for maintainability, it's better to do that. I don't know if you have seen this, but all the time on Facebook, I'm seeing people post these things and say, what's the outcome of this math problem? It's like this whole string of 1 plus 1 times 0 plus 1 divided by, you know, and the idea is everybody votes and 20 people all come up with different answers. And, you know, one of them is obviously right, and the rest of the people need to go back to high school or wherever. But the fact that you get multiple answers to what should be a simple math problem points to the fact here that order of precedence is something that sometimes causes confusion. We're not going to do a lot of really advanced calculations in an ABAP program. But if you ever find yourself stringing together a calculation that has the potential to be confusing, don't rely on just the rules of order of precedence. Put parentheses in as a way of avoiding any potential confusion on the part of someone that might follow you. One of the things that is unique about ABAP is operators and parentheses are considered keywords. And so they have to be separated from other statement elements by at least one space. So I think I showed you this on the whiteboard previously. If I were to do x equals y plus 1, I would have to do x space equals space y space plus space 1 period. Parentheses, the same thing. I would do x space equals space open parentheses space y space plus space 1 space close parenthesis period. Okay, So be aware of that. You might have noticed in what I just walked you through, the one exception to a space after something is if the very next character is the period for the end of line marker, then we don't put that last trailing space in there. This is the great thing about the ABAP editor, where if I start typing a statement like this, things are going to start turning red as a way of telling me that what I am doing here is problematic. And so, I got the period, I got the red there at the end. It's kind of interesting that it didn't highlight an error here before, but this is the way this would actually look as a valid ABAP statement. Okay? There's an old school ABAP keyword called move. We will never use it as is illustrated on this slide, but there is a really nice purpose for move that we will see later on in the semester. So although I'm showing you move var2 to var1, realize that like in the early days of ABAP, that was how you did assignment. But then very quickly they moved to the more traditional syntax underneath it, var1 equals var2, or var x equals 3 plus 7 times 2, as you see illustrated here. If we have variables of a different type, then automatic type conversion is attempted. So in other programming languages, this is handled differently, but if I am adding together an integer and a floating point number, it's going to automatically do the needed type conversion to come up with the answer that we would expect it to come up with in that given context. I do have a keyword that sometimes is useful that I can use in conjunction with data objects, and that's the keyword clear. Clear will allow me to wipe out the value of a particular data object. Now notice this, it resets the variable to the default type-related value. What I mean by that is it would reset C or string to the null string. It would reset an integer or a floating point number to 0. It doesn't mean that if I said data X type I value 7, this doesn't mean that that would cause clearing it to be set back to 7. That means that it's going to reset it back to either a 0, a null string, or something that would be similar to that given the overall type declaration. It's not going to reset it back to whatever the value is in the value statement at the time the data object was declared. Questions? There are a lot of functions in ABAP that are mathematical functions. I put some here in case we wind up ever wanting to use these in a program in the future. These are not in any way exhaustive. These are just common ones. ABS for absolute value, seal for ceiling, floor for floor, trunk for truncate, frac for just give me the decimal portion of the fraction, sign is going to be 1 if the number is positive, -1 if it's negative, or 0 if 0. And the reason why I'm showing you this is to show you, once again, how we space around functions. So I create data result type I, and then I set result equal to the ceiling of the literal string 3.2. And there's a syntax error in my code. Can anybody tell me what my syntax error is? Yeah, I need single quotes around that 3.2 because it's going to see that decimal right there, and it's not going to like it very well. I need to turn on my PowerPoint smart quotes off, so ignore the fact that those are arrowing different directions. Those are just traditional single quotes there around 3.2. But once again, notice the spacing. Name of the function, opening parenthesis butted right up against that, then a space, then the argument to the function, space after the argument, closing parenthesis and period. Now, I would like you to get in the habit of, if we ever have a quiz and I ask you to write a line of code, to try and write your code similarly. But quite frankly, if you're handwriting it, it's going to be really hard for me to tell. But clearly, when you're typing code in the IDE, you're going to have to make your code match up to this format, or the IDE is going to give your code right back to you. Okay? Questions? All right. I can create my own data types. Now, as a point of fact, there are two different ways I can declare data types. What we're going to start with is working on creating data types that exist just within the scope of one program. So we would call this a local data type declaration. And the idea here is this gives me the ability to be more specific than a typical type declaration statement or a typical data statement, and also allow me to add some semantic meaning to my type declaration. So the syntax here is keyword types, then the name that I want to call my type, then the word keyword type, and then the type specification. Now, welcome to the wonderful world of ABAP, where we have keywords that are singular and plural, and both very particular as to which goes where. Pain in the neck. Fortunately, if you're working within the IDE, it's going to help you out. For example, if I go here and let's say I wanted to add a types statement to my program, let's give me a couple of blank lines here at the top. Notice if I start typing here, T-Y, notice it's trying to spot me the word types, okay? And I didn't hit the key fast enough, but if I hit the tab there, it gave me the word types. It knew not to give me the word type, and then if I said types, my type, space, and now I hit a T, notice there it tries to give me the word type singular. Okay, so it's smart. It tries to help me write correct code here, but the types statement starts with types as a plural word, and then I give the name for my type, and then the word type singular, and my type specification. Now, the type specification follows the exact same rules as my data statement. So you might say, why do I need this? Well, I'm going to show you in a minute here where this is really, really, really quite essential. There are very simple uses of this types statement and then more advanced ones. In the simple usage of the type statement, it just gives me a way to create my own type that would be more semantically meaningful in my program. For example, if I create a data object and I say data, I should be writing in all caps, data, X, which would be a very, very poor variable name, but for the sake of illustration, I'll use it here, type, N, which is what? What's N? Numeric string, okay, length, 5, period. Well, you might look at that and say, okay, well, X is clearly a data object that's a numeric string of type 5, but that doesn't really tell you what that is. But if I were to do this, types, zip code type, normally I like to use the word type in my types declaration here, type zip code type, type N, length 5, that would now be a data type declaration. And then I could say data X type zip code type. And I'm having to break that just because I ran out of whiteboard there. So you can see quite clearly in this scenario right here, I've now picked up some semantic understanding of what's going on here. So declaring my own types, would be a very simple usage of it, gives me the ability to make my code more semantically clear, both for my development and the sake of someone who might follow me in maintenance. I could clearly do, here's some examples, types, user age, type I. Well, that's not incredibly useful, but then if I were to declare a data object, data user a or data I don't know, age, type user age, it at least gives me an understanding of what's going on there. Type ID code, type N, length 10. Type rate, type P, length 3, decimals 2. So I have now just declared 3 different data types. What students will often make a mistake on, and I want to caution you, is this is a type declaration. So nowhere on what we're looking at here as far as what's projected have we created an actual data object. A type statement would be expected to later be followed by a data statement that would actually create a data object of a specified type. Types cannot have user-specified default values in the types statement. Now down here in my data statement, I could do data X type zip code type value and then put a zip code there. I can do values in the data statement, but values cannot be part of a types statement. As I mentioned at the outset here, these types declarations only exist within the sphere of the program that contains this source code. Global type declarations are possible, and we will use those before the semester is over, but those are in the ABAP dictionary is where we create those, and so we're going to have to learn how to do that because the process is totally different. And the idea behind that would be I could create a data type that would then exist universally in the system and could be used in a variety of programs written by a variety of end users. And so that is a very useful technique, but it's something that we will talk about here in a moment. Yes?
On the data X type zip code, what's the extra type at the end for?
That is because I ran out of whiteboard space. The data type here is actually zip code type. And I do try, and when I name my type, and you notice I didn't really do this here on the slide, I usually try and give the type a name that clearly distinguishes it as a type as opposed to a data object itself. Questions? This slide I already talked about the like option, so I'm going to buzz through that. And also, for the sake of time, I'm going to skip over this quick practice so that we can talk about one more thing that you're going to need to know for your next homework assignment. Structured types. Structured types give us the ability to encapsulate multiple data elements in one data object. In PHP, I think we called these records. In C, they are called structs. I don't recall what they are called in Java. Anybody happen to know that right off? Maybe as we explain it more, some of you will be able to remind me what this is called in Java, but I'm guessing that you have worked with these before. The idea is, normally I create a data object and I call it age, and the computer goes out and sets aside a piece in memory for me to store the user's age. The idea behind a structured data type is I create one variable, let's say user info, and that one data object has different fields in it. A field for first name, last name, address, street, city, zip code, and so on. And so it's one variable, but has different fields in it, okay? In ABAP, we call those structures, and we create them using structured types. How do I make one of those? Well, I start with a types statement. Types, colon, begin of, and then the name of the structured data type I want to create. And keep in mind, I'm creating a data type here. Colon, and then I list the name of the field, and then the keyword type, and then I give a type definition for that field, just like we would have done in other contexts. And then I put a comma, and however many fields there are going to be, I just continue with these field name lines, okay? And then when I'm done, I have the statement end of the name of my structure, which corresponds to what was up here on the first line, followed by a period. So this now gives me an ability to create a single data object that has multiple fields in it. When I write my code, I reference the fields using the name of the data object dash the name of the field. So let's say that I created a type called user info type. And then I created, not typo, type, and then I created a data object called uinfo. And in my data object, I had a field for first name, for last name, and so on. I would identify those fields as uinfo dash first name, uinfo dash last name, uinfo dash address, whatever have you, the name of the data object dash the name of the field. And of course, if I created a user info type, I could have any number of data objects that are all independent of one another that are based on that type declaration. So let's look at an example. Types, here's a simple one. Username. Types begin of username type. And by the way, that convention is one that I like to use there for my type naming. I just give it a name and then underscore type. So types begin of username type. First, okay, so what's that? First is now the name of a field. So my username type is going to have a field in it named first that's going to be type C length 40. And it's going to have a field called last, type C length 40. End of username type. Now, I could have added a salutation field or a title field like Mr., Ms., Mrs., Doctor. I could have had a middle initial field. I could have added a suffix field for things like junior, senior, the third, and so on. Obviously, we could extend this to make this a more robust definition, but this is illustrative of it. I can have as many fields in my structured data type here as I need to, given the overall context of what I'm creating. So I create the type. I use a data statement to create a data object based on that type, data, friend name, type username type. And then, as I'm illustrating here, to load data into this, I use the name of the data object, friend name, a dash, the name of the field, space equals space, and then what I want to store in that field. So at this point now, friend name is a structured data type with two particular fields in it. And if I wanted to write these values out, I would use a write statement, and I would list friend name dash first as the data object to be written out. Some languages afford the user shortcuts. I think it's Pascal that allows you to give a particular name of a data object, and I think it's like using name of the data object, and allows you in lines of code after that to kind of save character strokes by not having to put in the data object name in the field every time. In ABAP, you got to do it this way. There's no shortcuts. You always have to put in the name of the data object dash and the name of the field. Anybody remember what these are called in Java? What's that? Well, you can do that. This could be a class because it's related to it. I just, seems like there's another name for it. I just can't remember what it was because it's been a while since I've done any Java programming. Any questions about this? All right. Let me take an aside for a moment and talk to you about your next programming assignment. I will upload this document to D2L later this morning, and the document that I'm about to show you actually calls for you to write 2 programs, but we're not ready to write the second program yet, so I'm going to edit the document to be reflective of that. And this particular assignment will be due, I'd like to be able to have these graded before next class, but let's do this. I will make this assignment due next Monday at 11:59 p.m., okay? So let's take a moment here and talk through this particular homework and make sure that you will have success and achievement. I'm not going to read you page 1. Page 1 of the homework tells you how to actually submit your homework, and you can read that on your own. So, our company tracks the following information for all of our employees. We have their name, which is stored separately as a first name, a last name, and a middle initial. We store their mailing address, which we actually store their street address, like 324 Elm Street, city, state, and zip, which are all different values. We store an employee number, which is an 8-digit numeric code, such as 14583748, and we store their date of hire. Well, I want you to create a structured data type capable of holding all of this information in one structure. Take some time to consider the appropriate types based on what this indicates as far as the information that's going to be stored. So this is going to be a structured data type, has a lot of fields in it. Everything that you see here is going to represent different fields, and this is not 4 fields. Just name is 3 different fields, and mailing address is, 4 different fields. So there's going to be a lot of fields here. What I would then like you to do, once you create the data type, create a couple of actual data objects and fill them with data for a hypothetical employee. So you're going to have a lot of code that says something like employee 1 dash first name equals Bob, employee 1 dash last name equals Smith. So there's going to be a lot of code there, but it's going to be pretty trivial code to actually write. Once you have filled 2 structures with data for a hypothetical employee, I want you to output the data 2 different ways. I want you to output each employee in mailing label format that looks like what you see here. Robert A. Johnson, 112 Elm Street, Johnson City, Tennessee, 37615. Notice not all of the information from the structure is represented here, but clearly parts of the structure are being used. So I want you to write that out for both the data objects. And the second thing I want you to do is I want you to produce a table. I want you to output a header, and then I want you to, underneath those header values, create a table showing the information for your 2 employees just for the fields referenced here. Okay? And there's some bullet points at the end that give you some helpful hints about how to make your date output in this format. But that is program number, well, I'm calling this homework 2, so this will be homework 2, the program that you will write, which will be due Monday evening of next week. My encouragement to you is start early, so if you run into questions, I can help you with that, but it won't be due until next Monday evening. So, having gone over the homework and now returning to this slide, do you guys have any questions? All right, let me show you just one more thing, and then we will, actually I might have time to show you 2 things, which means we can actually have 2 homework assignments. Mark, do quick. Constants. I have the keyword constant that allows me to create a data object that cannot have its value changed in the context of my program. So I could have constants, and notice it's plural, constants, the name of the constant, and then a normal type declaration. And for the constants statement, I have to put in a value. Why do I have to put in a value? Because it's a constant. I can't change it programmatically after this line of code is done. So if I don't put a value clause there, I've essentially declared a null constant that does me no good. So this looks very similar to the data statement. The only difference is we use the keyword constants. We have to supply the value, and the value of this particular constant cannot be changed. And I won't go into length as to why we need constants and the value they afford us. I trust that's something that you have discussed in other contexts. Well, the thing that we need to learn about next that will enable us to do the next of the programming assignments is this. There are some data objects that are maintained automatically in the system. For example, in just about any programming language, if we wanted to find out what the current time was, there's actually a data object we could use in our program that when we use that data object would tell our program to go out and get that from the operating system, and it would show the actual time. Well, in ABAP, there is a system-maintained data object that's a structured type, and the name of that data object is called syst. And we can find out all of the different fields that are in syst by using the ABAP dictionary. Now, here's how we do that. I'm going to open up a new transaction. I can go to the ABAP dictionary with transaction SE11. And so if I go to this ABAP dictionary screen and I put in data type, syst, S-Y-S-T, and hit display, it's going to show me this is a structure like what we've been talking about. It's a structure with 171 fields in it. Okay? It has as one of its field index, page number, tabix, tfill, tlopsy, tmaxl, toku, however you pronounce it. You can see, I can scroll through here. This is a structure that has 171 different fields in it. And all of these field values are maintained by ABAP automatically. Some of them are really, really specialized, and we'll use them later on this semester. Some of them, you can see, are declared to be obsolete. But notice if I scroll through here, and let's try and find one here, language key of text environment. If I wanted to find out what language the user was logged into ABAP using, whether English, German, French, Spanish, or whatever, that's stored in the langu field of this SYST data type. If I wanted to find out the client number of the current user, which in our case would be 313, I can find that by the MANDT field of this particular data object. Now you see there's a lot of these internal use and obsolete, but as we scroll through here we can find out like what operating system is the server running on? What version of SAP are we running? What's the current transaction code the user is executing? What's the name of our SAP system? Like we're using system, I think it's AB3. So you can see there's lots of very interesting things that are stored here. What's the login name of the current user? Well, I might want to grab that and use that in my program. So the way I do that is through this particular structure. Now, syst is actually aliased as SY. So one of the fields in syst was MANDT. And I happen to know from frequent use that is the client number of the user. So if I did this, keep picking up the dead marker, put that in my pocket to throw away, write SY-MANDT. Okay, this is a structure. This is the name of the data object. This is the field. That's going to write to the screen. If we run it, 313. It's going to write the client number. Okay? So I can look in the data dictionary, look at all the different fields there, and if I want to use those values in my program, this is the way I do that. The name of the data object is just SY hyphen and the name of the field. I will never assign anything to those values. The system maintains those values for me. Reference the values by using the identifier sy-component name. For example, sy-mandt will display the current client value. Now, some of the values are going to be fairly persistent in a system. For example, if I run all of my SAP infrastructure on the Windows operating system, when I ask, what operating system are you running on, it's going to always return Windows. But clearly, if I ask it, what's the username? Well, that's going to change with every user. So some of these fields will be very dynamic. Some of them will almost never change. We'll also see later on, kind of interestingly, that when I want to create loops in ABAP, I have loop counters that are part of this SY structure. When I have an error condition and I want to find out more about the error condition, I can query one of these SY values to find out what the error situation actually is. So we'll use this guy a lot this semester. So I'm excited about the fact that I can give you 2 programs for homework. I'm sure you're overjoyed by that as well, but you would have gotten to write this anyhow. I tell you here, I remind you that you use transaction SE11 and you're looking at the SYST structure. What I want you to do is I want you to look through that structure and I want you to create a program that will output the name of the field. So let's say, for example, sy-mandt. I want you to output the value, which in our case would be 313, and then I want you to just give a description of it. So your description here might be client number of current user. So I want you to create a program that's just going to output some of these values. Now, there are 171 different fields. A lot of those fields are obsolete. A lot of those fields have very particular purposes that we will use later this semester. So for the sake of your program, all I want you to do is I want you to look through that set of 171 fields, find 6 of them that you think actually have information that might be useful, some of which I just went through and talking about this with you, like the operating system, the name of the system, and so on. And I want you to write a program that will create a table and output, there'll be 6 lines in the body of the table. The name of the field, so it's going to be notice SY dash, the name of the field. This will be a literal string that you hard code in your program. And the description, you could make that exactly be what the description is in the dictionary, or you could type your own description, but this is going to be literal text of your own composition. But this guy right here, the value column, is going to be the value that you get when you write out that particular data object. Okay? So this is homework number 2. Make note of the fact that in homework number 2, you're not creating any data objects. The SY data object already exists. The other data up there, like the name of the field and the description, those are going to be just literal text strings that you don't need to put them in a variable. You just write them out to the screen using a write statement with the text to be written between single quotes. So you'll have these 2 programs to do for your homework assignment that will be due next Monday evening.